My name's Chris. I'm a software architect at Microsoft, and I'm going to be talking to you about durable execution on serverless platforms. So definitely a technical talk. A little bit more about me. So let's see, I've been an engineer at Microsoft for about 17 years now. I helped design and build much of the Azure Serverless FaaS platform. And also the creator of Durable Functions and maintainer of the Durable Task Framework, if folks have maybe heard of that before. Also a little bit of a generative AI fanboy, so I really enjoyed Ryland's talk yesterday. I don't know if anyone got to see that. But I'm also, I study Japanese in my spare time as well, so I put a little line there for that. Fun fact, actually, before today, I've given more public talks in Japanese than I have in English, despite the fact that my Japanese is pretty terrible. But if you can distract them with good slides, it usually works out okay. All right, so a little bit more about sort of where Durable Functions fits into the durable execution family tree. If any of you came to Replay last year, you may have seen a similar graphic that Maxim showed, where basically, a simple workflow service was sort of the roots of durable execution programming frameworks. Samar and Maxim worked together on that. Samar left for Microsoft. He created the Durable Task Framework, and then later went to Uber to go create Cadence with Max. A few years after that, I had sort of taken the Durable Task Framework and created Durable Functions out of it, which is basically sort of the serverless version of the Durable Task Framework. And so that's a little bit what I want to talk about today. There's a few other interesting durable execution platforms out there. I mentioned Dapper Workflow at the bottom there, which is sort of an open source variant of Durable Task Framework. There's also a few other interesting startups that many folks may have seen, such as Infinitic and more recently Restate. So definitely some very interesting projects going on there. But that's just sort of where we fit into the durable execution space. So we're kind of cousin technologies with Temporal. That's how I like to think about it. So what is Azure Durable Functions? Sorry, I'm having to read my slides over there because this screen is a little too small for me. But it's basically the Durable Task Framework, which is a library packaged as an Azure Functions extension. So the way that Azure Functions works is that there are a bunch of different trigger types that you can use to run your functions. These functions are like lambdas. And it's extensible, the type of triggers that you can have that run in our serverless environment. So basically, I took the Durable Task Framework, created an extension out of it for functions, and then sort of was able to come up with Azure Durable Functions that way. We don't call them workflows, we call them orchestrations, but we also have the concept of activities. And you can see a couple of code snippets there on the bottom, the left side being C#, the right side being Python. The programming model is very similar to what you would see in Temporal. A little bit different syntactically. You might notice, like, for example, we have these context objects. But otherwise, the basic idea is exactly the same, just a slightly different syntax. C#, async await. Python, we use generator functions, but you sort of get the idea of how that might work. All right, click. There we go. So a little bit more about serverless and functions as a service. So I often use them interchangeably, but when I'm talking about serverless, I'm really talking about FaaS, or functions as a service, which is sort of a highly opinionated subset of serverless. It's known as an event-driven programming model, right? So you have some event, whether it's a queue event or HTTP, that can then trigger your function to run. That's typically characterized by elastic scale, right? You don't provision your compute up front. The platform provides the compute for you and expands it or retracts it as necessary. Paper execution, so that's a very important characteristic of FaaS. So you're not billed based on CPU time strictly, like provisioned CPU time, but per execution of your functions, which if you're not running a lot of functions, that's really great because you can run these really cheaply. And of course, it's available in all major clouds. So most folks are probably familiar with AWS Lambda as being sort of the first ones to really coin the term serverless and FaaS. But then, of course, Azure Functions and Google Cloud Functions. Now, Google is interesting. They also have a product called Google Cloud Run, which many of you have probably heard of. I sort of see that as it's definitely serverless, maybe not quite FaaS, though, because they don't have the same programming model and sort of pricing model as, like the per execution billing, but it sort of still falls into that. The Cloud Functions is really the pure FaaS play. So one thing, when serverless really became popular, the community got together and came up with a set of principles or best practices for, how should you write your functions in FaaS? So, one of them was that, functions must not be long running. They must be stateless. They may not call other functions, and they should only do one thing. And so if you're familiar with something like Temporal, or in my case, it was the Durable Task Framework, you look at those rules, and then your next thought is, well, one does not simply execute durably on serverless, right? If I have a workflow, I need it to run for a week. That might exceed the function timeout, maybe. So, but to break it down a little bit more, let's talk about what some of the key problems are that need to be overcome if you want to get something like durable execution working on serverless. One of them, as I just mentioned, is function timeouts, right? Most clouds have a default of 5 minutes for your function execution. You can extend it out to maybe like 15 minutes, I believe in AWS, same with Microsoft. There's also this concept of double billing. So when I talked about that best practice of functions calling other functions, it's usually sort of referring to this. If you have one function that you're paying for its execution time, calling another function, and then maybe it has to wait for that function to return some value back, well, you're paying both for the function that's actively running and also the function that's waiting for the other function to run. And so you're being billed for two things, even though only one function is sort of actively doing anything. So that's a bit of an issue, and you could imagine, like, if you have a workflow calling an activity, that workflow is waiting for that activity to complete. You don't want to be billed for the time that the workflow is sitting there waiting in addition to the activity. So that's a thing. Scale to zero, that's one of the biggest challenges and also the biggest benefits of FaaS is how do you scale to zero? If you have a workflow type programming model that needs to be listening for new events, how do you make that happen? How do you go from 0 to 1 or 1 to 0? Elastic scale, sort of what are the parameters that you use to determine whether or not it's time to scale out? Do you rely, well, typically FaaS platforms don't rely on things like CPU and memory. Typically they look at sort of the event load. And so there's a question of, well, okay, with a workflow, durable execution type system, how do you do that? What metrics do you use to sort of make those real-time scale decisions? And then lastly, ephemeral compute, just the fact that the VMs or the containers that you're given to run your code, they're there, but they can be taken away at any time. And so if you need to do things like caching, that becomes a real big problem. Especially for something like durable execution where you may have a workflow and it's nice to sort of keep it in memory so that as it gets new events, signals, whatever, it can work with the in-memory copy rather than needing to reload the history from the data store every single time. So these are some of the key problems. So I thought it might be interesting to talk a little bit about how we solve some of those problems in durable functions, but of course talking about it in sort of a general way. So let's see, function timeouts and double billing. Let's start with that. So the solution that we sort of came up with this is basically to take that workflow function, or the orchestrator in our terminology, and break it up into multiple executions, stopping at each new yield statement in the case of this Python function here. So for example, the very first time that we invoke this orchestration, we just run that highlighted line there up until the yield statement. And once we hit that yield statement, we end the function execution right there. So we don't, the execution that you get billed for stops at the yield and doesn't resume until the function gets called a second time, in which case we run the first line and then the part of the second line and hit that next yield, and then we stop. And we continue this process until we eventually get to the whole thing. So what we've done is we've taken this simple workflow here, and we've actually broken it down into 4 distinct function invocations. And it turns out that each of those invocations are actually extremely fast, just a few milliseconds at most, because we're not actually stopping to wait for that activity to finish. And this is important for sort of avoiding the long timeouts, or the short timeouts that you get with a lot of the FaaS platforms. Because let's say, for example, if that activity down below wasn't a simple hello, what if it was something that took 2 minutes, and maybe we have like a 5-minute limitation for functions. Now, if you add that 2 minutes to the 3 calls that you see in the orchestrator function there, well, that's 6 minutes. You're going to exceed your timeout. But because we're able to break this down into small chunks, each of those orchestrator function invocations are just a few milliseconds, and so that allows people to be able to build a workflow that can run for really long periods of time, sort of bypassing the timeout limits. And that's something that gets a lot of people excited when they're sort of bought into serverless. They really want it, but they want to understand, how can I avoid these timeout limitations? Okay, so what about some of the other problems that I mentioned? Elastic scale, ephemeral compute. So I thought I could explain a little bit how we do that. But first, I thought it might be interesting to talk about a more naive approach to how you might solve that. So, one option is, let's say you have a workflow engine. I'll be a little bit vague about what that means. But maybe if it needs to run workflows or activities, it just calls out into HTTP to whatever FaaS platform you happen to be using, and that spins up Lambda functions or whatever to do those. Conceptually, it's very simple, which is one of the pros, and it solves the scale to 0 problem, right? Because, well, kind of. You still have to figure out what to do with that workflow engine thing on the left, but as far as all the other pieces of code, those can all scale to 0, which is nice. And this works with any FaaS cloud. They all support HTTP. But there are some problems with this design approach. One of them is API gateway timeouts, which I believe for Lambda is 30 seconds. For Azure Functions, it's a little bit more than that. But basically, it's something that's shorter than the actual function timeout itself. And so even if you were to keep your activities and things to be less than less than 5 minutes, you still have a gateway timeout that you have to deal with, which can be challenging. Function execution timeouts, network isolation, that can be a little interesting. That workflow engine, if it needs to talk to those Lambdas, and those Lambdas are in a private network, there's some interesting challenges there. And no container affinity for the workflow tasks. So this goes back to the point about caching. If you have a workflow that's loaded on one particular container and you need to dispatch a task to it, how do you sort of make sure that it goes to the correct container so that we don't have to reload the history every single time? So it can be a little bit more challenging than you might expect. So the way that we did it in Azure Functions, just to give you sort of a reference example, is we have this component that we call the Azure Functions Scale Controller. And basically what it does is it's a piece of infrastructure that runs in the cloud, and it periodically polls the underlying data source. We call it a task hub. More generically, we could talk about it as like a workflow state store. And it's polling and asking this question: how much work is there to do? Right? Are there any activities that have been scheduled? Are there any timers that have been scheduled, or new workflows that have been scheduled? And how many are there that need to be executed? And so if it finds some, and only when it finds some, it can go and start provisioning some compute to run the workflows. And in this case, the workers actually run directly within the container that runs your code. And so once they're up, those are able to start the polling process and start pulling in the work that they need. And because it's the pull model instead of the push model, you're able to get the affinity that you need as far as making sure that the workflows that you've loaded are able to stay in memory and benefit from the caching and those sorts of things. And they can just pull in messages as they need. There's another interesting aspect to it as well, which is dealing with the ephemeral compute. When we do need to scale down, one of the things that we're able to do is send a drain message to these workers and basically tell them, hey, you need to stop polling now because I'm going to take away your container or your VM. So please stop polling messages. Please finish any work that you're doing, at which point, once we're able to detect that that particular worker is no longer executing, we can go ahead and deprovision it and not interrupt any in-flight work, which would otherwise result in duplicate invocations. So with that, we've been pretty much able to solve sort of the key problems that I mentioned as far as durable execution. And I mentioned this not just to say that, okay, Azure Functions is cool, but this is sort of a recipe that I think, as even the temporal engineering team sort of thinks about what are some strategies for serverless. These are some of the things that we've done, which has sort of helped enable this FaaS type platforms to be able to run workflows. So with that, I thought it'd be cool to actually show a demo where I do a little bit of, I could sort of show you how we did durable functions, but I thought it'd be even more interesting, since this is a temporal conference, if I took the temporal SDK and enabled it to run directly on Azure Functions in a serverless way. So what I have here is a project that I created in Visual Studio, which is the primary editor that .NET developers and C, C++ developers use. So I have a function app, and here you can see I'm using the brand new .NET SDK, because .NET and C#, those are my main things. But anyways, I have just a simple workflow class. I have some workflow logic here. Oops, I am zooming. Why am I zooming? I don't want to be doing that. I want to be scrolling. Okay. Anyways, so I have sort of a workflow run method. This is a very simple hello world workflow. Hopefully something that you've seen in samples. Takes a name. There's an ability to query that name with workflow queries. You can do workflow signals to update the name and then finish when you want the workflow to finish. Not a super interesting workflow, but just one that sort of demonstrates the capabilities of the SDK. And then I also have a set of what we call functions here. And these are sort of the Lambda functions. And what I've got here is a set of HTTP triggers. So basically, we're exposing these functions over HTTP. And if you've never seen Azure Functions, one thing that you can do is you can actually define a whole bunch of these functions in a single file, even in a single class. And then after you deploy it, it'll kind of separate them out into their own things. But you can do it sort of in a single class like I've been doing here. I have an HTTP trigger. And one thing that I forgot to mention is that in this project, if I can open it, one thing that I did is I actually created an extension specifically for Temporal to work with Azure Functions. In this case, it's a project reference, but in the fullness of time, it would be something like a NuGet package. So anyways, if I hop back into the code here, where'd my code go? There it is. In that extension, gosh, my laptop is not happy with me right now. Let me click on the tab here. Okay, sorry about that. So one of the things that we also have in functions is this concept of bindings. And so in this extension, I've defined a temporal client binding, where just by saying, hey, I've got this parameter in my function, and I want it to give me a temporal client, the extension will take care of automatically setting up that client, connecting it to the temporal server, and making it available in your function. And there's sort of a JSON file that you can configure that'll actually show you. I don't know what's wrong with my mouse today, but this clicking is not working. Anyways, here it is on the top. Where you can sort of configure, for example, what's my target host for connecting to Temporal, what's the task queue, the namespace, those sorts of things. And so anyways, it's able to read that configuration, and I'm sorry about this. Yeah, I wonder if like my shift key got stuck or something. So anyways, you get the client, you can take that client, and then you can, call the usual methods, the start workflow. In this case, we just call the run method. We have a few other functions, such as, I want to get information. So again, I bind to this temporal client. In this case, one other thing that I forgot to mention is that you can define a route for these HTTP triggers. So in this case, if you do get hello / and then you pass in a workflow ID, you can then take that workflow ID in your function. And then you can use that to sort of get that workflow. And we return a description, which is going to just return it as JSON. Same thing if you want to get the results. We have something for that. So basically, I'm just exposing my workflow over some HTTP APIs. And we can do the signals to call update name. We can do the queries to get the greetings. And when update comes to the .NET SDK, we could do something like that too. But anyways, that is a set of functions we're going to be defining. And one thing that this extension also does is behind the scenes, so Azure Functions doesn't know anything about temporal, right? So I have this workflow. It doesn't know what to do with this workflow. But I actually have a source generator which goes and sort of generates a sort of fake function, which it then understands as a temporal workflow trigger. And so if I were to deploy this, which you can do pretty easily from here, you can just right-click and publish, and then you get a dialog that lets you publish it to Azure. So I've already done that, so I'm just going to switch over to an already published copy of this, Temporal Demo Linux. I deployed this to Linux. And you can see all the functions that we have in this application, one of them being the temporal workflow trigger, which was that special auto-generated one, and then all these HTTP triggers. So why don't we go ahead and run this? And so I've got Postman here. We're going to say start a new workflow. Let's call it hello temporal. I'm going to go ahead and send that. And then what it's going to do, and oh gosh, hopefully this is going to work. I've been running into some timeout issues with the .NET SDK. And I think I'm hitting that timeout issue again. I could go ahead and restart this app. That usually fixes it. Chad was telling me about this, and I think that might be what the problem I'm running into. But the cool thing about Azure Functions, too, is that if you want, you can also run everything locally. So why don't I do that so that we don't have to sit here and wait too long. But I'm going to go ahead and just run this project. Let's see if I can get everything working here. If you press F5 in Visual Studio, you can also run the functions runtime locally, and you get basically the same sort of experience that you would get in the cloud, except locally. And so you can see here it's discovered all my functions. It sort of understands the special new workflow trigger here. And if I'm going to switch over here, I think I might have something in my history where I can go ahead and, I'm going to send an HTTP post. Sorry, I don't have this set up in Postman, but I can do it here. And I can say something like, hello, temporal. If I can spell temporal, hello. And we should see a very similar response that basically says, yep, started a workflow. And if you actually look at the logs here, you can see that, yes, we executed that HTTP trigger function, but we also executed this workflow function called hello workflow. And you can see that it actually executed really fast, 31 milliseconds, even though if I'm to go and now query that workflow, just by doing a get, and I actually need to pass in this workflow ID here. Just give me a second while I type this out. This is just going to basically dump a description of the running workflow. We can see that it's still running, but the function isn't still running. The function completed, as it showed here. And then, we could similarly do, let's see, I think I defined it as /greeting. If I want to call into that query to get what is the greeting that I set, hello temporal. Again, sort of executes, let's see. So we can do that. We can, I could do a post, and I can update the greeting to be something else, which I believe is called update name. And this is, let's do replay instead. So that accepted. We could see some action if we look at the logs here. The workflow code ran again, basically processing the signal again, very fast, just ran for 9 milliseconds. So you could sort of see that, we're able to interact with this workflow in a serverless way. Basically, it's each of these executions are going very quickly and not, basically not charging the user for this long-running workflow that's being held there. And so we can go ahead and call, we called finish, and then if we go ahead and query the status of that again, we can see that the workflow completed. In this case, it was running just in the local dev server. It also works in Temporal Cloud, which unfortunately, I ran into that timeout issue with Postman. I think I hit the restart. It might work now if I were to try this again. And yeah, now it's working after I did the restart. In which case, I can actually go and see it running in Temporal Cloud. If I do a refresh here, there's that new hello workflow that I ran. So this project works. It's compatible with Temporal Cloud. And just to sort of hone in and confirm that, yes, this indeed works and is seen by Azure as proper function invocations. Let's see, I think the timing is a little bit off, so I don't know if the logs are going to be here. Okay, it looks like it is. You can see that, we actually ran this hello workflow function, which is actually the workflow. And we can even scroll over and see the latency, was pretty fast, just 46 milliseconds on this first run. So it's seen as a proper function execution. And, the user's only going to get billed for this 46 milliseconds and not for the full duration of however long that it's running. So anyways, we can go ahead and switch back to the presentation. So that's the demo that I wanted to show, just sort of showing some of the things that we were able to do, even with the Temporal SDK, to sort of get it running on a serverless platform. Now, just to be clear, it's completely a proof of concept. This is nothing that's necessarily going to ship, but I just wanted to show it as an illustration of the type of thing that we do with durable functions, which could apply to other durable execution platforms as well. So what's missing from the proof of concept that I showed? So support for other languages is one thing that's missing. So what I showed you is .NET. Slightly different work would need to be done to get it to work with all the other temporal SDKs. Let's see, event-based scaling. So that was just one thing that I didn't have time to sort of get in this proof of concept. Basically updating that scale controller piece that I showed you before. That's kind of a platform piece anyways. But the idea, one of the things that we would also sort of need for that is something on the temporal server that can tell us how much work is pending so that we can know how many VMs should I go ahead and allocate to get that going. So that's sort of another thing that could be explored. More flexible authentication options. It turns out setting this up was really painful, setting up the MTLS certificates on the function itself. I definitely didn't follow best practices when setting that up. Once we have API keys for the data plane, then this would work a lot more beautifully. So excited to hear that it's at least coming for the control plane. So then switching gears a little bit, I thought it might be cool to talk a little bit about some of the business impact that we're seeing with durable functions, just to sort of paint a picture of, or just help support the idea that, the durable execution thing is sort of legit, even from our perspective. It's not just, temporal hyping things up. Like this, we're seeing some really great things with durable functions too, including, billions of executions per day in our Azure public cloud. 65% of our top 500 enterprise FaaS customers are using durable execution, which basically tells us that they find a lot of value out of this. Beyond just sort of the mainline, okay, I've got my HTTP triggers, I've got my queue triggers. They're like, no, I need durable execution, and they're finding value in that. So in the last year, 30% increase in the number of subscriptions to Azure subscriptions using durable functions. So, there's some nice growth there. Even revenue, we're seeing a nice revenue growth. And, I apologize, I can't give, specific numbers for any of this. But just want to show you that there is a trend of growth going on. And it's going on very organically too, which is exciting. We don't have sort of a marketing and sales team to help us push this, but what we're finding is that our customers are sort of looking to solve the problems that many of folks are running into, and they're finding out about durable functions, they're trying it, and they're loving it. So similar story that you guys are hearing from other folks talking up here. And we have a lot of different industry verticals that are also finding a lot of value in durable execution. So again, just reinforcing the same message that's already being told, that durable execution, a lot of people are getting value out of it. It's making a lot of teams more productive. There are some pain points with durable functions specifically that I will call out, or at least the fact that it's sort of linked to FaaS. The highly opinionated programming model is one thing that folks sometimes complain about. They want to have control over the main method, for example, and be able to control the worker themselves, which we don't really sort of give you that option. And FaaS, frankly, is not ideal for all workloads. If you have sort of a low volume workload, it's amazing. Oftentimes you don't have to pay anything to host your stuff. But as you get to higher level workloads, sometimes it's better to have dedicated compute, which we have that option, but it's something you need to be aware of. And then we're more of a library. We don't have sort of a server product that sits in the back. We're just a library that points to whatever storage account you tell it to point to. Which is nice because it's sort of a lightweight setup, but it can also be a pain because you have to bring your own storage account, and we have to try to support you on your storage account. But not a problem with something like Temporal Cloud, so I'm a little bit jealous of Temporal Cloud. So anyways, key takeaways that I want folks to leave here with is that durable execution is fully compatible with FaaS. In spite of sort of the best practices that I showed before, it is possible to make it work. And so I just wanted to demonstrate that. It has a big business potential on FaaS as well. That's what we're seeing. And so, I'm really excited to see sort of as Temporal continues to grow and see how it makes its way into the FaaS space. Temporal workflows on FaaS is absolutely possible. There's a few things that we sort of identified that'll make it sort of more realistic, and hopefully that's something that we can continue to explore in the future. But that's basically it. So thanks for your patience with me. If you want to learn more about durable functions, aka.ms/durable functions, or you can scan the QR code. Feel free to follow me on Twitter too if you're interested in hearing what I have to tweet about it. So, all right, thanks so much.